We're on the last of our 10 FRQ topics. This is the topic on Taylor series. It's always FRQ number 6 every single year. Okay, so some key things about Taylor series. Taylor series have this set format. It's a power series. A Taylor series is a power series in this format. Okay, every Taylor series fits this. Okay, the powers are increasing as you go. All right, so know the Maclaurin series. A Maclaurin series is when C is 0. And know the Maclaurin series for sine, cosine, and e to the x. Sine x, it has this form, but it's always, all of the exponents and factorials are odd. Sine is odd and alternating in sine. Cosine uses all the even terms and still alternates in sine. Beginning at 1. Think of 1 as x to the 0, because 0 is even. Okay? E to the x is everything, evens and odds, starting at 1, and all positive. Okay? Recognize functions in the form something over 1 minus something with x's in it. The geosum form. Okay? And then use that. So for instance, this is in the geosum form. The top is 4x, so we're starting at 4x. R is x cubed, so to get from 4x to the next term, you multiply by x cubed. And then you keep multiplying by x cubed. This converges when the absolute value of r is less than 1, because it is geometric. Okay, the coefficient of the 5th degree term is always this. The coefficient of the 8th degree term is always this. So if you are asked to find the value of the 6th derivative, go to the term with x to the 6th in it and set its coefficient equal to this, and then solve. Okay? Remember that the coefficient includes the denominator. So the coefficient of x to the 6th here is this. If you're asked to find interval or radius of convergence, use the ratio test. Show all the work. Lagrange error bound. We talked about this a little bit in our last lesson. The error is everything that's not used in your approximation. So it is the exact, actual, huge series value. This should be series value. I'm going to change that for your notes. It's the actual series value minus the approximation. Okay? And that is always less than the error bound. The error bound is just that one term. Okay? Just the one term. You're going to be told what degree Taylor series is used in the approximation. Then you'll be given information about the next derivative, which you will put right here, because that's where the derivative goes. X minus c, you'll be given the x. You're approximating f of 1.2, that's your x value. You're centered at 2, okay? And then, so it's derivative, x minus c to the power divided by the factorial. That's your Lagrange error bound. It's not the error, because the error is this infinite. It's still infinite. The error is still infinite. The error bound is just that one piece. Okay? Absolute values, because error bound is always positive. Okay? Be able to take the derivative or integral of a series term by term using the power rule for these. That's a very common question. When you're writing a general term, check it when n is 2 to see if you get one of your terms. And then lastly, don't be surprised if you're asked to do something different. Just do what they tell you to do. Okay? All right, I need to fix that. All right, let's take a look at the FRQ that was from 2014. I know that this was a while back, but this was a nice problem to demonstrate a variety of things that they typically ask. Okay, a Taylor series for a function f about x is equal to 1, that's your center value, is given by this series and converges to f when the absolute value of x minus 1 is less than r. So this is the radius of convergence. This is how they state the radius of convergence. Part A, find the value of r. So if I'm finding the radius of convergence, so I know I use the ratio test. Okay, ratio test starts with a limit. Don't forget your limit. And then absolute values every time. Ratio test, absolute values every time. Okay, I'm going to go to my a sub n expression. It's right here. Here's my a sub n expression. And I'm going to replace every n with n plus 1. First thing I see is a negative 1 to a power. Because of my absolute values, I do not have to write that. So I'm not going to. It's just going to muddy things up, so I'm not going to put it. I'm going to replace every other n with n plus 1. So I have 2 to the n plus 1 times x minus 1 to the n plus 1 all over n plus 1. I'm dividing by the nth term, which is the same as multiplying by its reciprocal. So n over 2 to the n times x minus 1 to the n. All right, down to my ratio test now. Okay, as I take this limit, okay, the 2 to the n's, we can reduce those, right? 2 to the n plus 1 over 2 to the n. 2 to the n plus 1 over 2 to the n leaves me a 2 on top. 2 on top. The x minus 1's also reduce, leaving me an x minus 1. I'm going to keep my absolute values around that because it has an x in it. I didn't have to keep my absolute values around the 2 because the absolute value of 2 is just 2. And then for the n's, these n's do not reduce. These n's do not reduce. So the n and the n plus 1, they do not reduce, but as we take the limit, they go to 1. And that will always happen, right? So the answer to this limit is just what's there. I force this to be less than 1. I divide both sides by that 2. And now it's in the form that I needed it to be in. And r is 1/2. Okay? Part B. Find the first 3 non-zero terms and the general term of the Taylor series for f prime, the derivative of f. So this is the series for f. I need the series for f prime. So I'm going to be taking some derivatives. Okay? Now, lots of times in these problems, they say the general term, but they also write out terms. They did not do that this time. And since I need to take the derivative and I need to get the first 3 non-zero terms, I have to write out some terms of this. So I'm going to. So f of x, not f prime, just f of x is. Okay, does it start positive or negative? If I put a 1 in for n, which I need to do for the first term, if I put a 1 in for n, negative 1 squared is positive. So I start positive. And then I'll have 2 to the first over 1 times x minus 1 to the first. The next term, when n is 2, I'll be negative, and n is 2 here, so I'll have 2 squared over 2 times x minus 1 squared. The next term will be positive. I'm putting 3 in for n, 2 cubed over 3 times x minus 1 cubed. Next term will be negative. 2 to the fourth over 4, x minus 1 to the fourth, plus, and that would go on and on. And then I'm just going to write my nth term here. Okay? So now it's in a form where I can easily get the derivative. Okay, this power is 1. Chain rule. 1 times the front is just 2, right? When I decrease the power by 1, I'll get a 0 there. It'll be x minus 1 to the 0, which is just a 1. The derivative of the inside is just a 1, so my first term is just 2. Minus power rule, so chain rule with a power rule. So 2 times the front. When I multiply 2 times the front, it will reduce with this 2 right here. I'll be left with 2 squared times x minus 1 to the first power times the derivative of the inside, which is just a 1, plus 3 times the front. The 3's reduce out. I have 2 cubed x minus 1 squared minus 4 times the front. The 4's reduce. 2 to the fourth x minus 1 cubed, plus on and on and on, plus. Okay, let's do the power rule on this right here. If I multiply n times the front, the n's will reduce out, and I'm left with 2 to the n x minus 1 to the n minus 1. Yeah? That's the general term right there. So the first, they asked me to find the first 3 non-zero. I found 4, that's fine. I just didn't have to find that fourth one, but that's okay that I did. And the general term, there's the general term. So I found the first 3 non-zero and the general term for f prime. Okay, part C. The Taylor series for f prime about x equals 1 found in part B is a geometric series. Find the function f prime to which the series converges on its radius of convergence. Then use the function to determine f. Okay, well, first things first, let's find the function. They're telling me that this is geometric, and it is geometric. It is geometric. So f prime is geometric with first term 2 and common ratio. What do you multiply to get to the next term every time? Well, I'm multiplying by to get from 2 to negative 2 squared times x minus 1. What do you multiply by? Negative 2 times x minus 1. That is the common ratio. Therefore, f prime is equal to 2 over 1 minus r That is the sum formula. Oh, for goodness sakes. Okay. So that is using the A over 1 minus R. Okay? Alrighty. That's f prime. So I found the function f prime, which the series converges to. Now I need to find the function for f. So if this is f prime, what do I do to that to get f? What do I do to that to get f? Well, I'm going to integrate it, right? F of x will be the integral of this. Yeah? Now this has become an integration problem. So this is 2 over, I'm going to clean up that denominator. That's going to be a 2x. This is a negative 2, so I'm going to, when I add that 1 to it, it's going to be a minus 1, right? Yeah. So dx, yeah? Yeah. Okay. So this is, now I can integrate it pretty easily, yeah? So this is going to be the top 2, and then it's going to be an ln, but the bottom has a 2 in front of the x, so I need to multiply that by a 1/2. If I did a u sub there, I would get a 1/2 out in front. Yeah? Plus c, right? Plus c. So this is ln absolute value 2x minus 1 plus c. I keep looking over here at my other solutions because I did it slightly different, and I don't know why I did it that way, but I did it slightly different. My answer is going to end up being the same, but anyway. Oh well. Okay. Now I need to find that c. How do we find that c value? I'm not going to go up to the side. I'm going to do it right here. How do I find the c value? Well, what is the very first term of, if I go up to f of x, what is f of 1? What is f of 1? F of 1, if I put a 1 in place of every x, f of 1 is 0, isn't it? So down here, this is f of x, but I know that f of 1 is 0. So if I put a 1 in for x, I should get 0 here. Well, ln of 1 is 0, so that tells me that c is 0. So that tells me that f of x is just ln absolute value 2x minus 1. That's it. So that is true on the interval of convergence. Okay? Ended a little bit rough. I just tried to do what they told me to do. Let's see how it was scored. Part A, 1 point for sets up the ratio test. 1 point for computes the limit of that ratio. And 1 point for determines the radius of convergence. The answer. So 3 points for part A, 3 points for that ratio test. Part B, 2 points for the first 3 non-zero terms, and 1 point for the general term. I'm sure they split up those two there, but I don't know how they split it up that year. Part C, 1.4 f prime of x, that function, f prime of x, and 1.4 the antiderivative, and 1.4 the function for f of x. So the global average was a 3.1 on that problem. Okay, doke. One more here. 2015. Next one we're doing is from 2015. Okay. Global average was significantly higher than that last problem. Let's see. The Maclaurin series. Well, that already is a good thing because we're centered at 0. We like to be centered at 0. It makes our series much cleaner looking. So that helps. Is given by this, and look what they did for us. They wrote out some of the terms. That's nice. In that last problem, we had to write out those terms, but in this one, they wrote it out for us. And converges to f for absolute value x is less than r is the radius of convergence. Part A, once again, is use the ratio test to find r. So I'm going to set up the ratio test. Starts with a limit. Okay, I go to my general term. I'm replacing every n with n plus 1. This negative here, I'm not going to put in because of the absolute values. It will just muddy it. So I'm going to leave it 3 to the, if I put an n plus 1 in for that n, this will just be an n, x to the n plus 1 over n plus 1. Multiply by the reciprocal of the nth term over 3 to the n minus 1 times x to the n. Okay, the n and the n plus 1, they don't reduce, but when we take the limit, they will go to 1. So I'm ignoring those. I'm going to reduce the rest of it. So I'm going to have a single 3 on top because its power is 1 higher than this power. And I'm going to have an absolute value of x on top since its power is 1 higher than that power. And that's it. Force this to be less than 1. The absolute value of x is less than 1. 1/3. Divide both sides by 3. So r is equal to 1/3. That right there was worth 3 points. Part B. Write the first 4 non-zero terms for f prime, the derivative of f, and then express f prime as a rational function on the interval of convergence. First, let's write the terms of f prime. In this case, they already gave me f, so I'm not going to rewrite f this time. What's the derivative of the first term? 1. What's the derivative of the next term? When I multiply 2 times the front, the 2's cancel, and I'm left with negative 3x. Go to the next term. What's the derivative of this term? Positive 9x squared. Minus dot 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 plus. Okay. Multiply n to the front. N to the front will reduce with this n. And I'm left with negative 3 to the n minus 1 x to the n minus 1. Reduce your power by 1, yeah? Okay. So that is f prime. They did ask me to write the first 4 non-zero. Did I write the first 4 non-zero? No, I did not. So I'm going to come back and rewrite this and include the next term. What will be the next term? What's the pattern? minus 27x cubed, right? Oops, dot, dot, dot. I'm just rewriting what's above. Okay? All right. So I did the first four non-zero. They didn't even tell me to write the general term, did they? So you know what? I don't even have to write this general term here. So you know what I'm going to do? I'm just going to get rid of that. Because they didn't make me write it. If they had, that would have been correct. But since they didn't tell me to, oh, okay. All right. Now we're going to express f prime as a rational function. Okay. When you look at these, what f prime, this is geometric. F prime is geometric. The first term is 1. What is the common ratio? What are you multiplying by each time? Negative 3x. So f prime is equal to a over 1 minus r. A over 1 minus r. That's f prime. That's the rational function for f prime. This is the infinite series for f prime. This is the rational function for f prime. Part C. Write the first four non-zero terms of the Maclaurin series for e to the x. Period. Let's go do that. Let's write the first four non-zero terms for the Maclaurin series for e to the x. 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus dot, dot, dot. The first four non-zero terms for e to the x. Now use the Maclaurin series for e to the x to write the third degree Taylor polynomial for g of x, which is e to the x times f of x, about x equals 0. Okay, so g of x is e to the x f of x. And I want the third degree Taylor polynomial. Okay, well, e to the x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus dot, dot, dot. F of x is the series that they gave me. I'm going to copy that down here. X minus 3 halves x squared plus 3x cubed minus dot, dot, dot. I'm not going to put the general term that they gave, because I need the third degree Taylor polynomial. Is this the third degree Taylor polynomial? No, it's not, because it is not in the form of a Taylor polynomial. Okay, I need to go ahead and multiply this out. But I'm not going to multiply it out for eternity, so I'm going to approximate. I'm going to say, okay, I'm going to stop when I get to a third degree term. Okay, I'm not going to go to a fourth degree term. So I'm going to distribute. 1 times x is x. 1 times negative 3 halves x squared is negative 3 halves x squared. 1 times 3x cubed is 3x cubed. If I went further, I would have a fourth degree term, and that would not be in the third degree Taylor polynomial, so I'm not going to write that. Now I go to x. X times x is x squared. X times negative 3x squared is negative 3 halves x cubed. X times the next one would be fourth degree. I don't want the fourth degree, so I'm just not going to write it. Hence the approximately equal to. I'm just not going to write it. Next term. This times this will give me an x cubed. So plus, I'm going to write this as a 1 over 2. 1 over 2 x cubed. If I went further, I would have fourth degree. so I'm not going to write it. If I go to this term here, as soon as I start to multiply, I get a fourth degree term, so I'm not going to write it. So these are my only terms. Question: is this a third degree Taylor polynomial? No, it is not, because it's not in the form of a third degree Taylor polynomial. I need to write it in the form of a Taylor polynomial. Okay? There's a single x term, so there's that. Now I'm going to group all of my squared terms and factor out an x squared. I'm going to have negative 3/2 from that piece and a plus 1 from that piece. If you want to go ahead and add those, add them. You'll get a 1/2. That's fine. Now I'm going to do the same thing for my cube terms. There are 3 of them. I have a positive 3 from this one. I have a negative 3/2 from this one, and a positive 1/2 from that one. Now is it in the form of a third degree Taylor polynomial? Yes, yes it is. So this is where you have to get to get credit for this problem, to get full credit for this problem. Let's see how they scored this. Part A. I'll write that right here. Part A. They gave 1 point for sets up the ratio test, 1 point for computes limit of the ratio, one point for the answer, the radius of convergence. 3 points for part A. Radius of convergence questions are always worth 3 points, it seems. Part B, I think I'll put that here. Part B. 1 point was for the first 4 non-zero. I'm sorry, 2 points were for the first 4 terms. Okay, 2 points for that. 1 point was for this rational function. So 3 points for part B. Part C. 1 point was for the 1 point was just for the first 4 non-zero for e to the x. And then 2 points were for the Taylor polynomial for g of x. Okay, so that brings us to the end of our last FRQ topic. Again, I've completed all of these over the summer, and I'm still working on this cold. Thank you for suffering through my gravelly voice and my frequent stops of the video and stuff. So hopefully it was all right. Okay, it is crucial that you guys practice problems. The more FRQs you do, the more comfortable you will be when you see the FRQs on the actual exam.